Good morning. My name is Lois Mumbi from Kenya, and I am with my colleague Sensitano Siwale from Zambia, and we are addressing the topic whether the use of genetically modified livestock should be expanded to enhance the global food security. This topic is in Group 4, and yes, we are supporting the topic because we are in the Affirmative Team, and you're welcome to this presentation. So I start by saying that genetically modified livestock are animals whose DNA has been altered using modern biotechnology so as to introduce selected good traits like increased productivity, resistance to diseases, therefore making them more resilient to existing challenges. The relevance for applying genetic modification to livestock is that the world population is projected to get to 9.7 billion by the year 2050. This means an increased demand in food. Unfortunately, in places like Africa, where we have 25% of the world's cattle, we're only able to supply 9% of the global beef, while places like the United States, with only 6% of cattle, supply 18.6% of beef. This is because traditional breeding is too slow, but genome editing can rapidly produce livestock that are more productive even under stress like disease and also climatic aspects that cause drought and limited feed access. And also there will be less emission of greenhouse gases, hence environmental sustainability. Therefore, genome editing is not only sustainable but reliable in enhancing food security in Africa and globally. So in our constructive argument one, we say that genetically modified livestock are a powerful solution for food security and climate resilience. And as we can see in the figure below, by altering the DNA of livestock exemplified by cattle, we're able to eliminate things like susceptibility to diseases, susceptibility to low feed due to drought, and attaining heat tolerant and water efficient animals in 1 to 2 generations would lead to a 20 to 30% higher productivity under stress. With the innovation, therefore, we would be able to meet food security in low income regions by the year 2000. And this one shows that the genetic modification can be carried out across diverse livestock ranging from sheep, goat, pigs, and cattle, enhancing milk, meat quality, and constructive argument 2 focuses on the ability of genetically modified livestock to be superior to disease resistance and to have high sustainability as shown in the table below. We know that 20% of global livestock is lost annually to disease. However, using gene editing can reduce mortality by 30 to 50% in livestock. It also cuts antibiotic use by 50 to 70%. Therefore, we get a sustainable environment as we increase productivity because animals will not die or be of low quality due to disease. And as the table shows, there are specific genes which can be used to focus on suppressing specific diseases like mastitis and tuberculosis, which are among the leading causes of death in cattle and reproduction. Constructive argument 3 shows that genetically modified livestock lead to ethical, affordable, and sustainable way forward in the food security issue because smallholder income would increase by 15 to 25% due to the genetically modified livestock, which are withstanding drought and diseases. Additionally, the reduction of negative environmental impact results to sustainability, which could feed an additional 2 billion people. And then the ethically strict regulations focusing on animal welfare during the genetic modification are implemented and they meet the public concerns, ensuring that there is safety and the long-term cost for farmers fall dramatically, making the technology sustainable. Constructive argument 4 talks about genetic modified livestock preventing the next zoonotic pandemic. Would say that 75% of emerging infectious diseases come from animals and they are able to pass into human beings. Genetically modified livestock are made to resist viruses like the African swine fever and avian influenza. Therefore, the chain of transmission is broken at the source, ensuring that besides the animals, even human beings are healthy. And the final constructive argument says that genetically modified livestock reduce poverty and boost smallholder incomes. Studies show that widespread adoption of productivity enhancing biotechnologies like the GM livestock increases smallholder income by 15 to 25%, especially in developing countries. In the sub-Saharan Africa, livestock contributes to 35 to 50% of agricultural GDP. It's a major asset for poor families. Therefore, increasing livestock productivity is critical in solving poverty and its association with food insecurity. So, our team that was opposing this topic highlighted that environmental risks are associated with genetically modified livestock, and we wish to address this point by saying that although it's argued that genetically modified livestock pose a 25% environmental risk through gene flow and biodiversity loss, alternative research confirms that gene flow between livestock and wild species is rare due to limited natural compatibility. Modern genetic modification in livestock use sterility genes and isolated breeding. Therefore, they restrict trait escape. As a result, genetically modified livestock reduce ecosystem pressure by lowering feedland and water. Then the corporate and IP dominance challenge associated with livestock, genetically modified livestock, is a concern that multinational corporations may dominate these markets. Evidence, however, suggests that many regions already run public sector breeding programs, which lowers dependency on foreign farms. Additionally, patents are existent in conventional livestock genetics, yet local breeding still persists. Therefore, it's about proper policies whereby genetic modification in livestock can support national food sovereignty, but not a corporate. The highlight on health risk, where it's claimed that genetically modified livestock are linked to toxicity, allergies, and obesity, uh, can be explained by the evidence that over 2 decades of reviews, there is no confirmed toxic effects from approved genetically modified foods. In addition, all genetically modified livestock undergo strict allergenicity tests to avoid introducing harmful proteins to the consumers. Additionally, genetically modified chicken, which could have been said to cause obesity in the claim of our opposing team, have no experimental backing because obesity is based on diet and not genes. Many genetically modified livestock are being engineered to improve nutritional quality and not to. The ethical and consumer concerns, where transparency is required, does not mean that GMLs are unsafe. It means that labels are supposed to provide information and not evidence of risk. Moreover, when consumers receive accurate education, acceptance increases. And therefore, we can conclude that ethical concerns can be addressed by combining clear labeling and public education other than rejecting the beneficial technology just because people have been told to produce. Lack of information is a concern raised by the opposing team because it increases public fear. However, this does not justify posing genetic modification in livestock as an innovation because the root cause is a communication gap, and this is not a technological danger. Additionally, awareness programs raise public acceptance by 40%, and the solution is improved outreach, not stopping scientific progress. Then people can make informed. And in the closing statement, we say that genetic modification in livestock, it is a game changer. There is no dignity in hunger. Genetically modified livestock boost productivity and strengthen food security. It reduces poverty and prevents disease while supporting sustainable and climate resilient agriculture. Embracing this innovation is essential to secure a prosperous and resilient food future, not only for Africa, but thank you so much. Welcome to present any questions that could arise from this presentation. Once again, thank you for listening to us.